we are given in example 2 that a particle is moving along a horizontal line with a position function s of t equals t squared minus 4t plus 2. And so we know the derivative of this would be the velocity function. So this means that the velocity function should be 2t minus 4. And we know the acceleration function would be the derivative of the velocity function. So the derivative of the velocity function would be just 2. And so we're going to fill out a chart to help us begin to make more sense of all of these relationships. And so if we use our position function when t is 0, s of t would be 2. When t is 1, s of t would be negative 1. When t is 2, s of t would be negative 2. 3, negative 1. 4, it's 2. 5, it's 7. Okay. If we use our velocity function, and we find that our velocity starts at negative 4, and goes negative 2, 0, 2, 4, and 6. So this thing is just speeding up, and acceleration is 2. So it's just a constant acceleration of 2. And so just from examining these numbers, we can know some things about the particle's motion. So I know that initially the particle is at a position of 2. It's moving left because its velocity is negative, but since its acceleration is positive, I know that the velocity is that it's slowing down. It isn't moving to the left as much. At t equals 1, the velocity is still negative, so I know that the particle is still moving to the left. And since it's acceleration 2, it's still slowing down. I know that at t equals 2, its velocity is 0, so that means the particle is stopped. It's not moving at t equals 2, but its acceleration is still positive 2, so it's basically stopped, and it's going to start moving to the right now. And now at t equals 3 and on, it is moving to the right because the velocity is positive. And in all three of those cases, because the acceleration is now in the same direction as the velocity, the particle is speeding up because the acceleration and the velocity are now working together. And if we wanted to map what's happening with this particle, just on a number line, we know that it starts at 2, and in the first second it goes to negative 1, and in the second it goes to negative 2, where it stops, and in the third second it goes back to negative 1, and then it goes back to 2, and then it ends up way over at 7 in the fifth second. So it starts in one direction, stops, and goes back in the other direction. Now, we normally wouldn't do stuff like this for more complicated functions, and generally we're not really interested in much about the particle, except it's important to know when the particle is stopped and when it has no acceleration. We also want to know when the object is speeding up or slowing down, And so focusing on a few facts helps us out a lot. Right, so we're going to look at the relationship between the velocity and the acceleration and what that tells us about what a particle is doing. So first, let's talk about if the acceleration is positive, or to the right horizontally or up vertically. So if the acceleration is positive and the velocity is positive, then we know that the particle is speeding up. If the acceleration is positive but the velocity is negative, then we know it's slowing down. If the velocity is 0 and the acceleration is positive, that does mean that the particle is stopped. But we can anticipate it will be moving to the right because that's the direction of its acceleration, or it's moving up. Now when the acceleration is negative and the velocity is positive, right, they're working against each other, so the particle is slowing down. If both are negative, then the particle is speeding up. And if the velocity is 0, that does mean the particle is stopped, but we would anticipate it's going to move to the left because that's the direction of the acceleration. Finally, if the particle has an acceleration of 0, but the velocity is greater than 0, then that does mean that it's moving to the right or up. If the velocity is negative, but acceleration is 0, the particle is definitely moving left. And if the velocity and the acceleration are 0, then the particle is stopped. And we don't really know what it's going to do next. We can't anticipate what's happening. Let's consider a final example. There's a particle. It's moving along a horizontal line, and we know its position function. It is s of t equals t squared minus 6t plus 5. And we can do an analysis of this particle's direction, its acceleration, its motion, and its position. So let's start by finding its velocity. Well, the velocity of this particle, which would be the derivative of the position function, is 2t minus 6. And this would be equal to 0 when t equals 3. So this means that the particle is not moving, is stopped at the time t equals 3. Right, so we know that when t equals 3, the particle is stopped. And when t is 0, we know that the particle would be moving left, and after 3 it would be moving right. And we know this because the velocity would be negative from 0 to 3 and positive from 3 on. And at 3 is when it's stopped. Now some other things we can know. We know that the acceleration is just the derivative of the velocity function. So acceleration is, again, just 2. And now we can know some things about this thing. We know that it's always accelerating. It's never 0. It's never not speeding up. So some things about the acceleration is we know that it always has a positive acceleration. So here's 0. We'll mark 3 because that will relate to our velocity function. It's always a positive acceleration. Now we think about the motion. If we think about when it's speeding up and slowing down, remember that for velocity, from 0 to 3 it was moving to the left because everything was negative. And after 3 it was moving to the right because everything was positive. And we can see just by the way these things match up that in this area the motion is slowing down because the acceleration and velocity are working against one another. And after 3 the particle would be speeding up because they'd be working together, both in the same direction. Right, so there we know something about motion. And finally, we can make sense of the position of this particle and see how that relates to everything. When the particle begins, it starts at 5, and 1 second later it would be at 0. And so it moves in this direction. Another second later, just using the position function, it would be at -3. Then it's at -4, so it's definitely slowing down. Then it heads back to -3, so it's changed direction, which means it had to stop. Back to 0, back to 5, and just keeps going. So we have these models relating position and velocity and acceleration.